Okay, hello everyone. Let's start with the webinar. I think some more people will be joining during this hour and a half ahead of us. So, but we've already got some nice numbers for the audience. So let's start. Well, welcome everyone. I know it's been a while since we had our last webinar actually. But I'm really happy that today we've put together, but I think it's a really interesting agenda for this community event. So we're going to give you kind of a well overdue update on our integration and support for Kubernetes. And I'm really happy that we have Michał from the OpenNebula team to tell us the details about this integration. And we also are very lucky because we have some our good friends from SUSE joining us today to give us some more details about some of the technologies that we have been using actually for the OpenNebula Kubernetes Engine. So, well, welcome back to the webinar series, and specifically welcome back to this webinar on the OpenNebula Kubernetes Engine. So, very quickly, I hope my audio will be okay. Let me check just in case. Okay. So very quickly, just to let you know who the speakers today are. I guess you all know already, but we have Andrés and Raul from the SUSE team joining us. Hi, Raul. And Andrés is also, there you are. Hello. And they will be offering us like a more detailed description about, on one hand, the Ranger Kubernetes Engine 2, that's on the basis of the technological base of the OpenNebula Kubernetes Engine, and also the Longhorn storage solution. So I'm really looking forward to their presentation. And then we have Michał from the OpenNebula team, and he's hello, Michał. So he's one of the guys behind this integration, this really nice integration that we offer now to our community. And then Alberto, that's me most of the time. Okay, so very briefly, this webinar series we started during back in 2020, I think, during the what was the name of that day's COVID thing? Yes, that COVID thingy. We started this webinar series, and we've been keeping this series since then. In the last few months, we've been less active with these webinars because as kind of the physical events were resuming everywhere, basically. We've been focusing most of our community efforts on being back again in these kind of face-to-face events, but we do want to keep this webinar series alive. And today's is the first kind of the relaunch of this series in a similar format, but and following this idea that we had originally of bringing you interesting speakers and technologies from some of our key technological partners, like SUSE in this case. So go ahead and stay in touch and keep an eye on the future events that we'll be organizing, and also mention the OpenNebula conference at the end of the presentation for you to, as a reminder that we have the OpenNebula conference coming in a few months' time. But now I think it's time to start with the proper contents. And I know most of you are really familiar with OpenNebula. Most of you come from the OpenNebula community. You are users and customers. There's also a significant percentage of people who might not be familiar with OpenNebula as an open source cloud and edge platform. So very briefly, I promise it's going to be as a couple of minutes to give you an introduction of what actually OpenNebula is. So what OpenNebula is right now, after these years of innovation and development mainly around the edge computing side of the product, is it's an open source platform for you to create this abstraction on top of different infrastructure resources, from your data center to public cloud and edge providers and edge resources. And on top of that, it creates this abstraction for you to manage different workloads across this so-called cloud to edge continuum or data center cloud edge continuum. So all the capabilities and the features you had before for OpenNebula on your private cloud on-prem, now we're expanding that to also support this kind of heterogeneous infrastructure for you to be able to manage all those resources transparently as if they were on-prem resources in your traditional private cloud. So the integration we're going to talk today is part of that effort to not just support VMs from different technologies, as I'll explain in a second, but also, in this case, Kubernetes clusters as well. Most of you are already familiar with the interface and the interfaces that we are actually now in the process of improving and releasing new versions of this. The latest one is this the one provision interface that we're not going to use it today, because we're going to be the demo that Michał has prepared is based on an on-prem deployment, but this is one of the components that it's available for you in a standard OpenNebula environment, which is this catalog of cloud providers and provisionings for you to expand your private infrastructure with external resources on demand, bare metal resources mainly. So I mentioned the different technologies. We keep the support for a number of technologies and the possibility for users to combine different virtualization technologies. Some of you are using OpenNebula on top of your VMware infrastructure, basically on top of your vCenters. Most of you, including people, former customers of VMware, are transitioning and using our integration with KVM virtual machines. Also, some of you using system containers, LXC system containers. And one of the things we did a couple of years ago was launching this integration with Firecracker for managing micro VMs, which is pretty cool because you can run containers as micro VMs within OpenNebula as any other workload. So, and then of course, you know, there are a number of integrations with other technologies like Terraform or Ansible. And then today we'll talk specifically about how we manage this Kubernetes workloads in an environment that, as you know, brings all these kind of traditional benefits of a cloud and its platform, multi-tenancy, for instance, which is also quite interesting for Kubernetes deployment. You have access to the slides. There is a specific section about Kubernetes on our website. You can explore these benefits in more detail, but just to give you an idea very briefly why we pursued this integration and why we're keeping working on making this experience with OpenNebula and Kubernetes on OpenNebula an easy one and as smooth as possible, is because we actually believe in that OpenNebula provides some benefits to Kubernetes deployments in some cases in which you want to actually leverage both things: the flexibility of a Kubernetes deployment for managing applications, but also the power of OpenNebula to manage this very diverse and heterogeneous infrastructure in different locations and create these abstractions, and also manage the scale up and down of the infrastructure resources for your Kubernetes clusters. So this is some of the benefits you as OpenNebula users, I'm sure some of you are already using, along with the Kubernetes appliance that we have in our marketplace. And speaking of the appliance, this is actually the official presentation of this appliance, which it has been around for a while, but we realized we had never done a proper presentation of the appliance, and so it's taking place now. It's taking place now, but and actually, we're really interested to hear you and know your feedback. Those of you who have been using the appliance so far, because we're now starting the maintenance cycle of this appliance and producing the next version. So every feedback is more than welcome at this point to help us improve this appliance and this service for our users. I forgot to mention that the chat is available and it's open for everyone. We have a final questions and answer session at the end, but in the meantime, feel free to use the chat for your comments and again, we'll deal with the questions for the whole session at the end, towards the end of the webinar. Okay, but just to let you know that the chat is open and everyone should be able to write in there. So I'm going to just give the floor to our colleagues from SUSE to talk specifically about two of the components or two of the main elements in this OpenNebula Kubernetes engine. One of them is my cat. No, the other one of these elements is the Ranger Kubernetes engine. It's always sabotaging my video conferences, and the other one is the Longhorn solution for storage. And we wanted to have our colleagues from SUSE here to make sure that you guys understand the potential of these two components that we've integrated into our appliance. And then after that, Michał will show you firsthand how to put this appliance to work through OpenNebula Cloud. Okay. So Raul, Andrés, all yours. I'll stop sharing my screen now.
Raul,
so
the stage is yours.
Next slide, please. So, well, this is me. My name is Raul Mahiques. I am a technical marketing manager at SUSE, focused on security topics. Before SUSE, I was working as the MIA specialist architect at Red Hat, and before that, I held other technical roles. And today in this presentation, I will talk about the Longhorn storage solution for Kubernetes part with my colleague Andrés, who will tell you more about SUSE and RK2. So the floor is yours, Andrés.
Hello. First of all, nice to meet you all virtually. My name is Andrés Valero, and as you can notice, I'm Spanish. So I have a little bit different background than Raul, even though we met working at Red Hat as a specialist solution architect. I also worked as a consultant, but before that, I was just a sales guy with tech ambitions. And at some point in my career, I decided to move to the more technical side of things. So here I am now. And for today, we have prepared, first of all, a small introduction about open source on where this SUSE Rancher story comes. I guess that most of you know it, but just in case, we will talk a little bit about it. And later on, I will give you more information and background about RK2 and why RK2 is important and how it fits in solutions like the OpenNebula Kubernetes Engine. So first of all, SUSE is a very well-known open source company founded in 1992. We've been doing Linux and open source for a long time, almost longer than anyone. But in a certain point, we didn't have the relevance we wanted in the Kubernetes space. So SUSE acquired Rancher Labs, and Rancher Labs, it's a startup that was founded in 2014 in California that was all about Kubernetes, and they were the ones that developed Rancher Manager or Rancher, and basically was the first Kubernetes management platform out there. So in somehow, despite being different companies, we had a common ground, and that common ground was open source. Both of us loved open source. We were committed to open source, and all the code we always delivered, and we always will deliver as an open source, okay? So basically, with this acquisition, or however you want to call it, what we achieved was a better portfolio. We complemented each other gaps. So we had all the Linux story or on the Linux knowledge and experience from SUSE, and all the innovation about Kubernetes and of a startup like Rancher, right? So that allowed us to mix both of them and, let's say, be better as a one thing. And obviously, we keep collaborating with projects like K3s, Longhorn, Kubernetes, the Linux kernel. So as a whole, we're doing even more for open source. Basically, as you can see here, we can help you from data center to the edge with the Rancher and SUSE solutions. But today, we will be focusing on RK2 and Longhorn. So let's talk a little bit about the RK2 origin. Basically, Rancher had and has now a branch dedicated for the US government called Rancher Government Solutions. And the US government loved what Rancher was doing in the Kubernetes space, but they had some special requirements, right? So they were talking with Rancher and they, let's say, asked us to have a more security-oriented distribution, Kubernetes distribution, that should be easy to operate, but at the same time, close to upstream Kubernetes, which is not easy to achieve all these requirements, and also easy to deploy and scale up and down. So the guys started thinking, okay, all these requirements basically already exist in RKE or in K3S. And in case you don't know, RKE is the Rancher Kubernetes Engine, the first Rancher distribution. And K3S is a distribution that probably most of you already know, but fully focused on edge. So basically at home, we had the pieces we needed to deliver that solution. So what the guys did, basically, they got the usability, the ease of operations, and the deployment model from K3S. But at the same time, they got the alignment with the upstream project of RKE. So they mix it together, and the result was RKE 2. And many of you probably are thinking, what about security? Security is coming next, okay? So basically with RKE 2, we got a secure Kubernetes distribution that is lightweight, easy to operate, and is valid both from data centers and edge environments. So it's a very flexible distribution and doesn't need huge requirements. Basically, at the OS level, as you can see, can use OpenSUSE, LES, Ubuntu, RHEL, Rocky, Linux. So most of the biggest or more well-known distributions, but it also accepts Windows Server nodes for Windows containers. You know that Windows container is becoming a thing, and it's also supported in RKE 2. But remember, just worker nodes. Windows containers or Windows workers can be control nodes. The minimum hardware to run RKE 2 is, as you can see in the slide, very low. It can run with 2 CPUs and 4 gigs. And this is important for etcd. If you want to perform properly, you will need fast disks, SSD, NVMe, something like this, because otherwise the performance of etcd will be a little bit poor. And it can be deployed as a single node, as a compact cluster, or a fully HA Kubernetes cluster. So you have many options in one single solution. And now in the future, we are going to cover a little bit about the security. So basically, RKE 2 is designed to be fully compliant with the CIS, scans and CIS standards. So out of the box, it's ready to configure and pass these scans, okay? Also, everything is done with FIPS 140 compliance. So it is everything compliance with encryption. Also, it's compatible with APP Armor, Linux, MCS. So also another layer that usually cause problems with some Kubernetes distributions. And also, every time we push new code to the repo, all the images are CVE scanned. And when a CVE is detected, the image is upgraded, is patched. So we make sure that the images are always in the latest release possible. Also, these images are based in the sleeve-based contact image, or BCI. So basically, it's SUSE Enterprise Linux, a very small footprint for containers. So it's very secure containers, or well, images to be more concrete. The installation and the configuration of the RKE 2 clusters is pretty easy. Basically, it deploys as a single binary, like K3S does. And you can start with a single node cluster and then start adding nodes. And depending on how you label it, it will become a worker or a control node, okay? And of course, if you want to deploy a fully HA cluster, you just have to prepare a small YAML file that is a config file. And from there, you can just deploy. Also has full integration with Rancher Manager, will make your life easier when it comes to management, or of course here in OpenNebula. And it is close to Kubernetes. You can use things like CNI. So out of the box, you can use with RKE2, Canal, Calico, Cilium, or even Multus for SRIOV cases. So it's a very complete solution, not really big footprint, and pretty flexible, to be honest, and secure. And here, last is a small architecture diagram. So you can see the RKE2 server node. This is as a control node, a master node if you want. Okay, so if you see, it's basically like a Kubernetes node, what you will find in a control Kubernetes node, with the small difference that we have another pod that is the RKE supervisor that helps us with the management of the cluster and help us with the securitization of the cluster. So basically, it's very close to the original upstream project, but with some, let's say, steroids to make it better. And if you go to the working node, you will find basically what you will find in any Kubernetes distribution worker. Well, something I forgot is RKE1 is based on Docker, but RKE2 and K3S, they use containerd. So we also moved away from Docker to a solution that is more standard, open, and lighter. So this is basically the introduction I wanted to make to RKE2. I hope you like it. And now I leave you with my colleague, Raul.
Thank you, Andrés. So next slide, please. So what is Longhorn? Longhorn is a Kubernetes native solution that provides distributed and highly available storage inside a Kubernetes cluster. For Longhorn, simplicity and ease of use are key things. But as with any storage solution, it follows the principle of least surprise, because nobody wants surprises with their precious data. And besides all this, it also aims to be lightweight and fast. What it does is basically run multiple replicas on different nodes, making sure that the data is synchronized between them, and then it presented as a single volume to Kubernetes for it to attach to a workload. It can work in any certified Kubernetes cluster, and as it is cloud native, it is very easy to manage and automate the same way you do as with any Kubernetes native application. It is, of course, reliable and stable, and currently a CNCF incubating project with a history of being used successfully with production workloads. Next slide, please. So Longhorn, this is a bit of history, just for knowledge. So Longhorn started as a closed source pre-Kubernetes era application in 2014. By 2016, it got open source and rewritten in Go, with reoriented to work with Docker. From there, it started to add more features like support for S3, Kubernetes, disaster recovery, etc. And by 2019, it became a CNCF sandbox project. 2020, the first GA version was released 1.0. And in 2021, with version 1.2, it became a CNCF incubating project, which for those who don't know, these are projects considered to be stable and that has been used successfully in production environment. Especially since it became a CNCF project, it has grown significantly. And now, last year, December, the version 1.4 was released, which bring more features like volume bit protection, volume trim support, online volume expansion, etc. Next slide, please. So what are the requirements to have it running? Basically, we need first a Kubernetes environment running version 1.221, 1.21 or newer. For the hardware, we recommend a minimum, well, we need a minimum of 3 nodes, and we recommend at least having 4 gig of RAM and 4 vCPUs. For the disk, it's recommended the fastest, the better, of course. So SSD or NVMe or similar for performance, but you can also use normal HDDs if they meet the performance requirements. I mean, if it's not too slow. There are more, these requirements can be found on the website I listed at the bottom of the slide. And sorry. For the operating system, it has been tested on SLES, OpenSUSE, RHEL, etc. But basically, any Linux distribution used in a certified Kubernetes cluster should work fine. It works on ARM64 and AMD64 architectures, and it's in experimental state for S900, S390X, which means it may be supported later in the future. So for more information and more details, and also if you want to, instead of checking by hand, you want to use a script to check these requirements, you can visit the website I listed at the bottom. I will put it in the chat later. So now, next slide, please. So how does it work? It has 2 main parts. The manager, which is simplifying, responsible for the creation and management of volumes in the Kubernetes cluster, and the engine, which handles the replication of the data across multiple replicas and nodes. So we can say the manager is the part that deals with the user and the Kubernetes, and the engine is the part that deals with the data itself. So the engine is a Linux process that runs always in the same cluster node as the pod that uses the volume. And so it's per volume. And it uses multiple replicas to synchronously replicate the volume data across multiple nodes. These replicas are also Linux processes, and each process has at least 2 of them. Each volume has at least 2 of them. This is designed this way so that if something happened with one engine, the function of the other volumes won't be affected. Next slide, please. The manager is a pod running on each node of the Kubernetes cluster as a daemon set. It handles the API calls from the UI and the CSI plugin, and also communicates with the Kubernetes API server. So if there is a request to create a new volume, it will launch a Longhorn engine instance on the node where the pod which is going to use this volume is going to be located, and it will create a replica on each node where the data will be replicated. Next slide, please. So what are the key features? So as I mentioned before, provides enterprise-grade distributed block storage for Kubernetes used in real-world production workloads. It allows you to do theme provisioning and create volume snapshots. With the UI, you can easily manage them as well as easily do backup and restore volumes you have created. to or from a secondary storage like NFS or S3 compatible object storage. And it can also expand online your volumes, so you don't need to schedule downtime if your application is running out of space. It allows you to schedule snapshots and backups, so you need to work your own scheduler. And upgrades aren't disruptive and actually pretty straightforward because it follows cloud native principles, so it's automated. And also supports read-write many volumes, encryption of communications, and bitroot protection to prevent data corruption. And as I mentioned earlier, you can either use the GUI or issue CRDs to Kubernetes, so it can be automated easily. And now I hand over to Alberto. Thank you.
Great. Well, thank you guys for the details. It was really interesting to know more about your insight about these two technologies that we think are really are really interesting for the work we're doing. And also I want to also acknowledge that the commitment from SUSE Ranger to transfer Longhorn to the CNCF. I think that was a very interesting move, and actually tells a lot about your commitment, guys, with the future of the cloud native ecosystem. So congratulations for that. I'm going to share my screen now, and then I'll give the floor to my colleague Michał to get into the more details about the OpenNebula Kubernetes Engine, the OneKE appliance. So Michał, all yours. Just let me know whenever you want me to move to the next slide.
Hi, my name is Michał, actually.
Sorry. that's awesome.
Yeah, I'm a cloud engineer in OpenNebula, and I'm going to introduce you to OneKE OneFlow appliance. Can you switch the slide? So yeah, in the appliance, we actually use RKE2 as like a main Kubernetes engine, and it's using Canal for networking. We also install additional components like Traffic and Metal LB to respectively implement ingress, and Metal LB load balancers for on-prem. And of course, we use Longhorn as this distributed storage. So basically, this OneKE is kind of at least it's supposed to be like a easy to use solution that comes with all these things. Like you deploy it, and you can basically you should be able to deploy most of the Helm charts. Can you switch the slide? Yeah, so like OneKE is actually a OneFlow appliance, and OneFlow is a service that can be enabled in OpenNebula. It can be used for orchestrating clusters of virtual machines. So like basically you can divide your deployments into roles, groups of virtual machines of similar type. And OneKE consists of 4 of these roles. First one is VNF, which stands for Virtual Network Functions. It's like very similar to virtual router stuff in OpenNebula, and basically it has a couple of functions inside of the cluster. So like first one is it's implementing NAT. Because like to deploy OneKE, you need 2 virtual networks, like private and public ones, and VNF implements NAT between the private and public networks. And also it runs HA proxy instance that actually implements control plane, like load balancer for the control plane. So later you can actually connect to the Kubernetes cluster from outside. I mean, to the cluster, and you can also connect to HTTPS and HTTP endpoints from the ingress. Other roles are just master role that implements control plane, worker nodes that you run your workloads on, and we implemented like a special storage role that deploys workers, but like these nodes are labeled and tainted in a way that if users deploy their pods, they will not be actually deployed onto the storage nodes. So like we just wanted this to be more stable. Like we never wanted to run like additional stuff on the storage nodes. It's worth mentioning here that usually, along with the OneFlow service, you would also want to enable OneGate service in OpenNebula. And OneGate service allows for virtual machines to communicate with each other and the OneFlow service by simply exchanging string values. And like for the OneKE deployment, it's actually required that it's used together with OneGate. And it's important that each VM in the cluster actually is able to connect to OneGate. Without this, your cluster will not be created. Next slide. Yeah, so I already talked about VNF. It's just a load balancer, and it implements NAT. It's based on Keep Alive, this VRRP protocol that is so you can actually scale it up to multiple nodes and have like a HA load balancer for the control plane, basically. Next slide, please. Yeah, and we deploy Longhorn as a like solution for like persistence storage. As I said before, like we label and taint nodes, so it's not possible to deploy user pods into those storage nodes. Yeah, so like there was recommendation on the previous slides that at least 3 Longhorn nodes are deployed, but like for simplicity, we deploy one, and I mean, it's always possible to scale it up to more. Next slide, please. And we deployed traffic as a ingress controller, and we automatically expose HTTP and HTTPS ports from it. Yeah, and it supports like standard ingress documents and ingress route documents inside of Kubernetes, and it's actually implemented as a node port service inside the Kubernetes, so the HA proxy instance from the VNF is able to actually connect to traffic, and you can access it from the outside. Next slide, please. We also support and install Metal LV. There are like 2 ways you can use it. One is ARP layer 2 load balancer, and second one is BGP layer 3. So like by default, we deploy the first one, so you can use it like locally in your on-prem infrastructure. It's actually unconfigured. It doesn't have like endpoints if you don't specify ones, but you can configure them if you like, or you can even provide like a custom config. Next slide, please. Yeah, so now we will have this demo part. Next slide. So in the demo, we will just use on-prem like infrastructure, just the normal OpenNebula instance that has nothing weird. It's just normal one, and we will download the appliance from the public marketplace, and we will deploy the service. And at the end, inside of that Kubernetes cluster, we will deploy a simple example application. It will be Nginx instance that will use Longhorn, and it will actually use the ingress controller in that case. So to deploy OneKE, you need properly configured one gate and one flow services, and you need 2 virtual networks. And one of them should have access to the public internet. Is it running, this demo? Oh, yeah. So the one gate service needs to be accessible from at least one of the 2 virtual networks, and usually you have to make sure to adjust listen address in one gate server config. Depending on your setup, you can use public IP subnet for the public network, or you can configure something like this destination NAT. The private network should use one of YANA reserved private subnets. That's because of the network address translation. The OneKE appliance comes in 2 flavors. One is C and EE. Currently, the only difference is that EE flavor has been designed for more of an air-gapped installation. So you can download the appliance, which consists of virtual machine templates and QCOW disk images, all from the public OpenNebula marketplace. And inside the demo, you can see that we already downloaded the appliance, and now OpenNebula is actually downloading images in the background. VNF is already downloaded since it's like a smaller one, and those 2 gray ones are still downloading. They're a bit bigger. So we have to wait for them to download. The demo is actually in real time, so like nothing has been cut off or cut out, and you can actually experience the real deployment. So we have to wait. Yeah. So let's deploy it. You need to provide some configuration for the deployment. You have to pick both public and private VNets, like so. And you have to provide the external VIP endpoint. This is another from the public network. You can use it to access Kubernetes API and ingress endpoints from the outside later. Next is internal VIP endpoint. This is another from the private network, and this is internally used as a default gateway by all RK-E2 nodes. Then you can configure an extra SAN just to access Kubernetes API that way later. And it's important that we always enable NAT because of network address translation that is needed between 2 VNets. Here you can change HTTPS and HTTP ports if you want. And the last parameter is like if you want to deploy multiple clusters in the same VNet, you have to provide this for this VRRP protocol. Yeah. So while this instance is deploying, we can take a look closely at roles. The first one is the VNF role. As we said, is responsible for NAT and control plane load balancer. Then the master role that forms the control plane, worker role that runs your pods, and the storage one that runs the Longhorn and has like attached special disks to keep the data. You can also scale each of those roles. Like we won't do it here, but it's possible. You can do this manually or use auto scaling if you want. Here we can take a look at the appliance itself. So this is actually the master node. You can go and see how it's deploying. You can see various synchronization routines here, and you can see also that we reconfigure VNF instance via OneGate. Actually, this image is EE1, so it actually is for the air-gapped installation. So like currently, it's actually decompressing Docker images that are actually used by RKE to start. So we have to wait a bit for like all of these images are extracted. Let's just wait. Shouldn't be that long. Yep.
It's a nice piece of pixel
Yeah.
art anyway.
Yeah, actually, if you have any kind of trouble with the appliance, that's the first place you should look in that log and in general in journal CTL logs, because like this appliance is based on the Ubuntu 22.04. And yeah, so now RKE2 master instance is being deployed, and we are actually waiting for the kubelet to be up and healthy. It should be quick. So what's interesting, all the roles are deployed at the same time, but storage and worker nodes are actually waiting for the master, like for at least one master to be up. Yeah, so RKE2 master node actually deployed. We can confirm here in Sunstove that master role it's switched to running. So now when actually we have a running master, we can download a kubeconfig file. It's kind of complicated command in this environment, like your environment will probably be different. Yeah, and we adjust the config itself to point to different server URL. Yeah. And this is this example that we will be deploying inside the cluster. It's just a simple application. It consists of persistent volume claim taken from Longhorn. This is like just a simple deployment that deploys one pod, one replica of Nginx, and actually mounts the volume claim. And here we have just a standard service and ingress route object from traffic that actually creates the ingress. It's very, very simple. Yeah, but like first, maybe let's wait for other roles to be fully up. So you can see here that despite they are starting at the same time, they actually are waiting for the master node to be up. So they are still joining. You can actually connect to them just like we connected to the master node, and look at logs. Like in oh yeah, they are up. So now we will deploy this example. So you can see here it failed creating ingress. That's because like a whole cluster was starting and traffic was not up. So we actually can repeat, and now it's working. And now we have to wait for all the resources to be up to just show the running application. First one is the persistent volume claim. We have to wait for Longhorn to create the volume. And then this volume will be mounted inside of this Nginx pod you can see on the top. This will take less than a minute, I think. It should be, yeah, it's bound. So now Nginx can start because persistent volume claim is there. So it's container creating and should be running. Yeah. So now, because we created ingress root objects, we should be able to just see the result in the browser. This is actually using public IP in this example, so it's exposed to the public internet. And that, I believe, concludes the demo. If you want to learn more, there is dedicated documentation page. And it's worth mentioning that it can be upgraded. Like we don't provide OpenNebula way to upgrade that appliance, but you can use RKey tools that system upgrade controller, and RKey's Helm integration to actually upgrade it. There are more topics in those documents, so like feel free to look at them. Thanks.
Great, thank you very much for that. I think it was a very comprehensive demo about the appliance and how to use it from a traditional OpenNebula environment, right? I mean the on-prem private OpenNebula cloud. Obviously, there is the components that we didn't use, or some of the features we didn't use. So like this one provision tool for incorporating resources from cloud providers. But the idea was just to give all of you kind of a brief introduction to actually how to use this appliance pretty quickly. Okay, so just to finalize, I'll ask you to, if you have any questions, put there on the chat, and then the speakers will be able to see there's been some interaction already in the chat, so thank you for that. So if you have any specific questions, just put it there while I'll show a couple of final slides. One of them is obviously, as always, the invitation for you to try the latest version, Electra version 6.6, and also to keep an eye in on the OpenNebula conference that we have at the end of May. It's already scheduled, and you can already register online. And we'll be publishing the program in a few weeks' time. So yep. So thank you, everyone. Special thanks to the yeah. Someone found the gecko there. Yeah, there it is. Great, Jordan. Actually, there are two of them. There was another one in another slide. Anyway, so thank you, everyone. Yeah, go ahead and put your questions on the chat, and then my colleagues will provide some answers and some insight. I think we already have some questions there, right? Okay, so there was a question by Jean-Sebastian about the upgrade of the cluster. I think that Michał, I think you answered that already. Online training. I don't think we have any specific training right now about the Kubernetes appliance of the use of Kubernetes. There's the general there's a general training, but I'll write it down because it might be useful in the near future to produce some specific online courses for, or at least some kind of more in-depth detail tutorial for that. So thank you for that, Dirk. Okay. There's some question from Alberto. Can Longhorn be used to provide the storage for the 1D data stores? Michał, any answer to that?
No, I mean, there are no plans for that kind of stuff. We support a couple of data stores like LVM, shared local storage, and we don't plan to use Longhorn for that. Yeah.
Although I have to say, in some of the innovation projects in which we are now involved, there's already there have been some conversations about this. So maybe not directly for the product in the short term, but we might be doing some kind of testing, kind of experiments in the near future anyway. There's also some question about using the OpenSUSE image. That is a possibility, yes. We haven't discussed it yet. Probably, again, within some of the innovation projects that we are doing with SUSE as one of the partners, this might come up at some point in the next few months. Yeah.
Yeah, we basically used Ubuntu 22.04, but like it should be possible to change it if yeah.
Mm-hmm. Yeah. And then there's a question from Jesus about the deploying the service using Terraform provider.
So like there were plans to make some better integration with the provider. Like currently, we haven't done this. I'm not sure if it's like completely possible. I mean, there are some OneFlow resources that you can do using Terraform provider, but we don't really know at this point.
Mm-hmm. Also, I mean, we'll take note of all these suggestions here, obviously. Yeah. Just also remember that you have at any point you have the community forum, the OpenNebula community forum, to actually share this stuff and also submit kind of or share your feature requests. I mean, there's a formal process through GitHub, as you might know, but the community forum as well is a good place if you want to test the waters, let's say, also with the rest of the community, and suggest some improvements or some integration for this appliance or for any other component in OpenNebula. Just remember it's available at any point. Another question for you, Michał, from Alberto.
I'm guessing that the cluster list would be at local storage for data stores and then take advantage of Longhorn replication in the OneKE. Yes, that's a good idea. It doesn't make sense to use like replicated data stores, because like if you're gonna use Longhorn, then you would like unnecessarily replicate this multiple times. So yeah, that doesn't make sense.
What about the OpenNebula API?
Yeah, you should be able to deploy it with the API. Like you can actually deploy it from the console, and the console actually uses the API underneath. So it's possible. Yeah, we actually in our integration environments used comments and like not the Sandstone. Yeah.
Also, just a reminder that we are recording the webinar. It will be available on the same registration page that you used on the webinar section of the website. It will be there. The video it will be on YouTube, and it will be embedded in there as well. and just give a couple of days or so. Okay, so if there are no more questions this time, I think we can call it a day. I think it was a really nice resuming of our webinar series. So thank you very much, Michał, for the for the demo and for the technical insight from the engineering team. And then thank you, Raul and Andrés, for joining us today for this session. We're really happy here with us and getting our community to know you and the other way around. So as we are also looking at different ways in which to kind of come closer to SUSE's technology as well, I think this is a nice step in the right direction. So yeah. Thank you very much, and we'll stay in touch. Thank you everyone for joining us, and keep an eye on the OpenNebula conference, where we're also trying to have some sessions with our friends from SUSE, and also specific sessions on Kubernetes on OpenNebula. Great. Thank you very much, and see you soon, guys.
Thank you.
Bye bye.
Thank you. Bye bye.